Okay, today's lesson is 4.5, graphing other trigonometric functions. So we're talking about, we did sine and cosine first, and now we're going to talk about the other four. So just like we've done in the past, when you see an equation, you want to know the general shape of it, and you want to know some key points. And in this particular, in the trig functions, just as we've been doing, we're going to have 5 key points. So to start off with, tangent function, remember, is sine over cosine. So wherever I have cosine equal to 0, I'm going to have an asymptote. So whenever you have anything that's got a fraction, those graphs are going to have asymptotes. So all 4 of these are going to have them. You're going to have to know how to give the equation. So I'm going to talk about that. What I've highlighted in green is the basic what you might consider the easiest period to remember of the parent function. Okay, so what you have to know about the tangent function, you want to know that the period is pi. You want to know that the graph rises as you go from left to right. So when I start here, this is going to rise. You're going to see different. The cotangent is going to fall. Okay, so that makes it kind of an easy way to figure them out. However, anyway, so the thing about it, so you have your period is pi, and when you want those key points, you need to know, first off, where the asymptotes are. And so if you notice, these asymptotes are at negative pi over 2 and pi over 2. Well, this pi over 2, the one on the right, is always half of your period. So that's kind of what starts my key points, is whatever period I have, I'm going to go to half of that. I'm going to go to half of that and label it 1 point. The opposite number on the other side of 0 is the other asymptote. Halfway between the asymptotes is a 0, and then halfway between a 0 and an asymptote to the right, I go up 1, and halfway to the left, I go down 1. And so that is the essence of it rising, but this is basically your A value. So if halfway between I went up to 2, those are my cats fighting in case you can't hear that or can hear that. If halfway between the 0 and the asymptote you go up 2, then you would have a 2 in front of the tangent because that's stretching it. Okay, so the other thing I want to talk to you about is the reason I'm pointing out this first asymptote is because when you have to go write the equation of the asymptotes in your problems, it's going to look something like this. X equals whatever you name as the first asymptote plus the period times n. Okay, it is also symmetric to the origin and an odd function, which is going to come in handy in the next chapter, but I just thought I'd give you a preview. All right, so the cotangent, as I just said, it's got the same period, but it falls. So notice that its first asymptote is at pi, and it always is at the end of the period. So the tangent has the first one at half the period. The cotangent has it at the end of the period, which makes the other side 0 because I've got to be pi units apart. Remember, cotangent is cosine over sine. So wherever my sine is 0, so it doesn't look like there's an asymptote here, but there is. And those are all multiples of pi. So they call the first one at 0, which if you have 0, you can do that, but sometimes you don't. Okay, so that means my equation is going to be x equals pi times n. Again, it has symmetry to the origin and is an odd function. We're going to learn some properties of those odd functions. Okay, moving forward. Okay, cosecant and secant. So on these two, you've got to remember what it is the reciprocal. What is the cosecant the reciprocal of? And cosecant is equal to 1 over the sine function. This is something I keep saying, I don't know why I did that, is that these don't start with the same letter. So if I have the cosecant starts with a C, so its reciprocal starts with an S. So over here, the secant starts with an S. Its reciprocal is the cosine. So it's equal to 1 over the cosine. Okay? So if I talk about the graphs again, so let's look down here. Our period for the cosecant function is 2 pi. And it starts at 0 and ends at 0. But on these functions, there's also one halfway in between. But the key is you want to remember that it starts at 0. So this is the sine function, and we know the sine starts at 0, so 1 over 0 is undefined. So this is going to be the key of knowing the difference between these two functions. Cosecant is 1 over sine, 1 over 0 is an asymptote. Secant is 1 over the cosine, and 1 over 1 is 1. So secant is the one that straddles the y-axis. Still has a period of 2 pi, but its end, actually go this way, it starts at negative pi over 2, which is 1/4 of your period, because 1/4 of 2 pi is pi over 2. And it ends, if you add 2 pi to negative pi over 2, you get 3 pi over 2. And that's how you're going to get those things when you have to answer them. Okay? Symmetry. Again, the cosecant, because it's 1 over the sine, is odd. The secant is even. It is symmetric to the y-axis. And here are our equations of our asymptotes. If you notice again, okay, in the secant and cosecant, they add half of their period. In the tangent and the cotangent, you add the period. So we're going to go and do some problems just like you're going to see in Delta Math. Okay, I hope you're printing this out or writing them down because it's going to be very useful to you on the test. Okay, so this is basically what we've talked about. You have y equals a times any of our 6 trig functions times a times a trig function of b parentheses x minus c plus d. A is the stretch, vertical stretch. It's called the amplitude on a sine and cosine, but all the others, y'all, amplitude is max minus the min divided by 2. So if these things are going on forever and ever in these directions, opposite directions, these go on forever and ever, there is no max and there is no min. So whenever you're asked for an amplitude on these problems, it's going to be none because there isn't one. Okay? Easy. Gimme question. Okay? So A is the amplitude or the vertical stretch. B is affecting your period, and I'm going to talk about them again. C is your phase shift, and D is your vertical translation. So let's go look at what you're going to have to do. Identify the amplitude, period, phase shift, asymptotes, and midline of this equation. So basically, you're telling us all that we need to be able to graph it, but you're not going to have to graph it. So you just got to be able to answer these questions. Okay? So as I just said, my -2, this number out front, is my A value. B is the coefficient in front of X, but this is not the phase shift unless that coefficient is 1. So the best thing for us to do now is I need to factor out the 6. So that's going to be 6. And when I factor out, I'm dividing. So 6 divided by 6 is my 1x minus pi over 6 because I'm dividing by 6. Okay? And I'm just carrying the 3 down there. So my 6 is my B value. Pi over 6 is C, and 3 is D. So when I'm going through and answer these questions, what is the amplitude? Well, I just told you the answer is none, every single one of these. Okay? The only time it's going to be something different is if you have sine or cosine. What is the period? Okay, this is the tangent function. Okay, and this is something that you have to know, so write it down if you don't. The period of the tangent function is pi over b. It's the parent function is pi, so you divide by b if there is a b value other than 1. So in this problem, it's going to be pi over 6. So what's my period? Pi over 6. Okay, the phase shift is your c. So what's my phase shift? It's pi over 6. Now that's one thing you got to be careful of. This is x minus c. So it's always going to be the opposite of that number is what you're going to put in here. So it's going to be pi over 6. You would put negative pi over 6 if that said x plus pi over 6. Okay? What are the equations of the asymptotes? I'm going to come back to that because that's the hardest question. What's the equation of the midline? That's your D. And y'all, it tells you here so that you'll remember, okay? It's an equation, okay? And the midline of the graph is that part that is halfway between these. Like this is a relative max and a relative min. Well, what's halfway between those is 0. So that's your midline on these of the parent function. Okay, what's your midline here? Excuse me. It's that halfway point between the asymptotes. So again, it's 0. It's your vertical shift. So what's my vertical shift? D. So I'm going to have y equals 3. So what are the equations of the asymptotes? Now remember I told you the asymptote for a tangent function is 1/2 the period. So what is 1/2 of pi over 6? Well, that's pi over 12. But I have a phase shift. So if I have a phase shift, pi over 6, it moved pi over 6 units to the right. So that first asymptote, I'm going to add pi over 6 to find it. And pi over 6 plus pi over 12 is equal to pi over 4. Pi over 6 is our phase shift. That's PS. So that means that my new first one is at pi over 4. Again, equation of the asymptote. So that's x equals pi over 4. But this is what I was underlining in all of these, y'all. You've got to, actually it's not this one. If it's not 0, you have to add something to it. And in the tangent and the cotangent functions, y'all, what you're adding to it is the period times n. So what is the period of my function here? It's pi over 6. So I'm adding plus pi over 6n. So you have to go calculate. This is calculating the first one, which in this case was half our period, plus the phase shift. Okay? That's the hardest part of the problem. All right. Identify amplitude, period, phase shift, asymptotes, midline of y equals 3/2 secant x over 3 minus pi, close parentheses, minus 2. Okay? So, sorry, my cats are going crazy. All right. So first off, secant. It's not the tangent or the cotangent, so you got to remember what is the reciprocal. What is its reciprocal? So the secant is the reciprocal of the cosine. So I'm thinking about the cosine when I do it, and the reason I do that, that would be for your period purposes. But I still have 3/2 is my A value. Okay. My B value, I have a number with this x, and so x has to be by itself, so I'm going to take it out because then I'll be able to identify the phase shift. So I factor out 1/3, and I'm left with x minus, and when I divide by 1/3, y'all, that's like multiplying by 3. And one way to check yourself is it's easy, is if I distribute this back, 1/3 times 3 is 1. But otherwise, just use your calculator. Class calc will do it. Pi divided by 1/3 gives you 3 pi. So that makes 1/3 equal to my B, and 3 pi equal to C, and D is my -2. -2, that's where you first graph things, y'all. So I'm going to go down here and say y equals -2. That's the easy one to figure out. Okay. My period. What is my period? Okay. Since it's related to the cosine, the period is going to be 2 pi over B. Okay, my B is 1/3. So that's 2 pi over 1/3. And when you divide by fractions, you keep change flip. So I'm keeping 2 pi, changing from division to multiplication, and then flipping my 1/3 to 3 over 1. And when I do, I get 6 pi. So my period is 6 pi. What is the phase shift? Well, that's my C value. So that's 3 pi. And what are the equations of the asymptote? It's x equals, okay? And remember I told you on the secant up here, this first one here is going to be 1/4 of my period. So it doesn't matter which one of these you use, okay? Just make it easy for yourself. But the asymptote is at 1/4 of the period, so 1/4 of 6 pi is 3 pi over 2. And then I have to add my phase shift. Okay, my phase shift is C, so that's 3 pi. And 3 pi over 2 plus 3 pi is equal to 9 pi over 2. So I'm saying my asymptote equation is x equals 9 pi over 2. And the other thing, with the tangent and cotangent, you add the period, but with the secant and the cosecant, you add half the period. So that's half of my period is going to be 3 pi. So I'm going to add 3 pi n. And n just takes care of all the asymptotes that you have. Okay? So you might pause. That's one example. The cotangent is very similar to that. Cosecant is similar to that. So go do those problems. Pause, and then come back and finish watching. Because this is the other type of problem that you have. So the other type is, here's a graph, and you've got to give me the equation. Okay? So my equation is going to look something like this. Again, what we just talked about. All right. you've got to go find the A, B, C, and D of it to write the equation. All right, so when you're looking at your graphs, kind of the first thing to do, one, you probably want to determine what trig function you have. So if it looks like this, you should have narrowed it down to two of them. And that would be either the secant or the cosecant. Okay. And so then I'm looking to see, does it cross the y-axis? The secant, remember, we'll have these parabolas will be crossing the y-axis. The cosecant won't, because it'll have an asymptote at the y-axis. All right, I got to figure out how to pause. And I don't know how to pause. There it is right there. Okay, hopefully that will be a little more civil. Okay, so I was talking about whether it was secant or cosecant. It does not cross the y-axis, so that I know it's going to be the cosecant. So I'm going to have y equals, and I know it's going to be the cosecant of something. Okay, so the next thing might be, I think is easiest, is to go see what my D value is. That's finding my midline. So my midline, and the order doesn't really matter so much, y'all. The midline, I'm looking, as I mentioned to you before, the distance between the bottoms and the tops of these parabolas. So that is going from, looks like 6 to -2. All right, and so halfway between that is my D, and that is 2. So I'm going to have +2 at the end. And the distance from the midline up to one of the parabolas or down to one of those parabolas, however you wish to look at it, okay, is your A value. So A is going to be 4. Now, the thing that you have to be careful about is that in my cosecant graph, y'all, first of all, there's more than one way to do it, okay? There's more than one right answer. So if you're absolutely convinced that yours is correct and you get marked wrong, let me know. Okay, but this has an asymptote right here. And if you remember back in our parent function of the cosecant, there's an asymptote here, and to the right of that of the y-axis, it goes up. So ours actually goes down. So since it goes down, that means it's been flipped. So that's why I need to have a negative sign in front of it. Okay. So the last thing I'm going to do is, and because I have an asymptote here, I don't have any kind of phase shift. So really all I have to do is worry about the B value. And to get that B value, I need to find the horizontal length of a period. So whether you go from, a max to, a max to a max, basically you're looking for the exact same point, same Y value going in the same direction. I've mentioned that before. But I know there's an asymptote here. And if I have a full one there and a full one there, then my next asymptote is going to be here. So that's really the easiest way to find it, is if you can go clearly from using 0, because then there's no subtraction to figure out that my period is 4 pi. And it's cosecant, which is related to the sine, so that is equal to 2 pi over b. And I generally cross multiply. You can switch them, but cross multiply and divide. Those pi's are going to cancel out. Boom. Oh, that was really fat. That's what I messed up on. I just realized what I didn't do. And so b is equal to 2 over 4, which is really 1/2. And so you have 1/2 x. So I am going to go back up here and tell you that I didn't talk about these key points. Okay. The key points of the cosecant and the secant. Okay. This cosecant is 1 over the sine. And the key points for my sine were, it starts at a 0, ends at a 0, halfway between is 0, halfway between the first two is a max, and halfway between the last two is a min. And everywhere I had a 0, I have asymptotes. And then I draw parabolas away from my midline. Okay, the secant is 1 over the cosine, and cosine starts at a max, ends at a max, halfway between is a min, halfway between the first two, the max and min are zeros. And you can just carry that pattern forth. But the point of that is, if you know one set of key points, then you know them all in that case. So that's kind of helpful. Okay, the next graph, you're looking at it, and I hope you can tell it's not cosecant or secant, because it's got these little things that don't look anything like those parabolas. So I'm looking at it and I'm thinking, does it rise or does it fall? And this graph is clearly falling as I go from left to right. You trace one of these things and I'm falling. So that means it's cotangent. Okay, but I mentioned to you also, it could be the negative tangent of x because I've just flipped the tangent and shifted it over. It's probably easiest to think of as cotangent, but whatever, you know, like I said, whichever floats your boat. So I've got, when I'm looking at it, okay, I'm going to go down here and find this period first. So cotangent, I have an asymptote at 0, and I have an asymptote right here. Okay, so that is from 0 to 3 pi. And I did that because then I know that halfway between is right here. I kind of missed that dot, but y'all got the right idea. Come on. Ooh, try that again. Okay. And that 0, that means that this point right here is my d value because my d value is going to be on those zeros. So if I come up here and start off and say, okay, I'm going to have y equals, and so the other thing I talked about is if I go halfway between a 0 and the asymptote, which if it's 1, 2, 3, halfway between would be right here. Okay, so this is the other key point, and I only went up 1. That's only 1 unit, which means the number in front is just a 1. Okay, we talked about that it's cotangent, and then we just talked about d is -4, so at the end I'm going to have -4. So the last thing I got to do is figure out my b value. Okay, my period is, what did we say, 3 pi. So period is 3 pi, and 3 pi is equal to pi over b, because cotangent and tangent are pi. Cross multiply and divide, and you find out that b is equal to 1/3. So we have 1/3 x, and that's all you got. So I'm going to do 2 more real quick. And then you can, so I have 1 of each. You shouldn't have any trouble doing this and figuring out which one is which when you do your homework. Okay, what's the equation of the graph? Again, it is, this time, this one is rising. So if it's rising, it's going to be tangent or, of course, negative cotangent. Okay, but we had our tangent straddling the y-axis. So this kind of goes along, which means there's no shift in it. So I'm going to go ahead and use the tangent. All right. That means that I have an asymptote. Now, I'm going to go what's completely on the graph. So my asymptotes are from here to here. So they go from pi over 6 to pi over 2, which is just 2 tick marks. So halfway between is right here. Okay? So every 2 tick marks is an asymptote, and then halfway between, so every other one is a 0. So this is really basically a 0, which means that that is my midline. So I have y equals, I'm trying to figure out if I go halfway between these two, do I go up just 1 or do I go up more than 1? Well, I think you can see that this point is just up 1. And since it's just up 1, then there's a 1 in front. I don't have to write it. So I'm going to write tangent of x. My d value is +1. So I'm going to have +1. And now I'm going to go do my period to figure out what is my b value. So my period, y'all, if you don't start at 0, then you can't just use this number. You have to subtract these two. So pi over 2 minus pi over 6. If you're using class count, do 1/2 minus 1/6. And the answer will be 1/3. Put that pi back in there. So your period is pi over 3. That's equal to pi over b. So surely y'all can tell me that that means that b equals 3. So my b value is 3. So I have y equals tangent of 3x plus 1. All right, last one. It doesn't look anything like this guy. So this is my parabolas going away from my midline. So this is secant or cosecant. And so at this point, I'm going to look and see what's happening at my y-axis. And that looks like it's a low point. It's intersecting at that point. So that tells me that I have cosine or secant in this case. All right, and then I can start up here. Actually, before I do that, let's go do. So we're going to go find the distance between the lowest point of one parabola and the highest point of another, because that's telling me that's going to help me find my midline. So between those, I go between -1 and -5, and halfway between is going to be -3. Okay? And that also tells me that the distance from the halfway to one of the bounds is my a value. So I'm going to have y equals, my a is, how far is it from the midline to that point is 2 units. Okay? And it is intersecting at 1, not -1, so I know it's positive. So I'm going to have 2 times the secant, and my d is -3. So now I got to go find my period. Okay? Now, if this is a minimum, a low point, then the next low point is over there. So that looks pretty easy to see that my period is from 0 to 4 pi, which of course is 4 pi. That's equal to 2 pi over b. Cross multiply and divide. B equals 2/4, which is reduced to 1/2 x. So we have y equals 2 times the secant of 1/2 x minus 3. And that is all we have to writing equations and writing equations from the graphs and then knowing the information from the equation. If you have any questions, one last thing I wanted to do for y'all, okay? And that is in your homework. And the first thing you have to do is identify the 9 trig graphs. So when you're identifying these graphs, I'm going to do some for you just to kind of show you how easy it is to do, because there's also a graph in here you haven't seen before. It happens to be in the next section, okay? But they're all the parent functions. So you're looking at this one and it straddles. So there's no shifts or anything like that. It's rising, and rising means it's y equals tangent of x. I got to go click in there. Click in there. Y equals tan of x. Okay. Another one. I'm going to do this until, okay, well, that's the same one. Okay, it looks exactly the same. Y equals tan of x. It is rising. Okay. Are they not going to give me a new? Okay, this is a different one that I wanted you to see, because this isn't like anything we have. So I want you to go find a point. Okay, this point is 1, 0. Okay, or actually, let's go with, I'm going to go with this one, pi over 2, because this will make more sense to you. This is the point 0, pi over 2, but what this graph is, y'all, is an inverse. So if you find this point, and this is has the coordinates, I'm going to see if this works, y'all, real quick. I hope it does. All right, this point right here has the coordinates of 0, pi over 2, and I just told you it's the inverse. So if you switch that, you would have pi over 2, comma 0. Oh, I didn't do very well. Oh, I can't erase with it. Okay, pi over 2, 0. What coordinate, sine or cosine, okay, which one of those functions is 0 at pi over 2? Okay, so the one that is 0 at pi over 2 is the cosine. So this is the inverse of the cosine function. Got to come back down. And so you write it like that. So when you get something funky, it's going to be an inverse function. So I'm trying to do some examples. So if you can't remember it, you want to write this down. Okay. This is falling. Okay. And the falling function is y equals the cotangent of x. All right. Here's one where I have my parabolas. Okay. So this is either cosecant or secant. Okay, it straddles the y-axis, which means its reciprocal is 1, and that means this is the one that starts at the max, and that's my cosine function. So it's the reciprocal of the cosine function, which is the secant function. Let's see if I get another inverse. If you can, here's another one that's an inverse. Okay, so this one says pi over 2, 1 is this point here. Okay, so what function has a value of 1 when you have pi over 2, and that is your sine function. And I'm going to put this in a different way. Okay, arcsine is another way of writing the inverse. So I want to tell you, sometimes it's a little bit easier to type, but if you notice, these are the same thing. So you can either have arcsine or you could have sine inverse, but it's what you get when you flip the coordinates, and we'll talk about it more in 4.6. But that will help you get through identifying your 9 trig graphs. All right, if you have any questions, please don't hesitate to come see us. Thank you so much for watching, and y'all have a great day.